Okay, I have the track now set up, and I just want to point out the layout here in the classroom. I've got my lab manual available so I can consult the instructions as I need them, as well as the table of data that we're going to be creating with this experiment today. And just to point out what's been done here, we have the stop block at the end of this cart. I can't place it at 0 on this particular track because the 0 position is all the way towards the end. So what I've done is I've placed this stop at exactly 10 centimeters, and the plunger of the cart places the cart a little bit farther away from that stop position than 10 centimeters. So what I've done is I've placed a stop block on this end to reference the back of the cart against, and with this block of wood here, I can reference the position against this tape measure, and you'll notice that this plunger is now 110 centimeters away. So 110 centimeters relative to this 10 centimeter position means that this cart will travel 100 centimeters. I leveled it using a level here. You can see that we're pretty close. More importantly, as I push this cart and allow it to rest, it no longer slides. So I have a stopwatch set up on my phone that we'll be using to collect this data. And I'm going to place a block of wood underneath one end of the track behind the view of the camera. So I think we should be able to see the event now. We've got a block of wood elevating the track. We can see our stopwatch and the cart itself. So I need to release this cart and start the stopwatch at the same time. When the cart strikes the stop at the end, I will stop the stopwatch. So here we go. That was 3.7 seconds. And so I'll point out on the lab sheet here that I did mark the displacement at 100 centimeters, and that first time trial was 3.7 seconds. So I'll reset the stopwatch and prepare to take another time. The cart is up against the starting position, and I will release the cart and press the start button on the watch again. That time it took 3.84 seconds. After reset, we'll take another measurement. Oops, and I messed up there. I clearly pressed the stop button way after the fact. So let's restart that and redo that trial. That was 3.9 seconds. So I'm writing that down on my table of data, 3.98 seconds. Reset, collect again. I got 4.7 on that one, 4.07 seconds. And then the last one for this group. .72. So on the table you'll see that we've got 5 data points, and we'll perform the mathematical analysis with that in just a second. For the next round of trials, we need to move the cart stopping point or starting point 5 centimeters closer, so we'll do that off camera. Okay, so what you'll notice here is that I've reset the starting position of the cart. This block of wood is indicating 105 centimeters. So that means that this plunger tip is 95 centimeters from the end of the track, or where the stop block is. We still have the same single block of wood underneath the legs over here, so we should be able to collect our data with this new position. I'll reset the timer from before, and we'll make another series of data collection. So here we go. Release the cart at the same time that we press the start menu on the timer. Okay, it looks like that stopped at 3.53. Reset the next one. I stopped that one at 3.88. Reset and collect again. Hopefully you can see why we're collecting this so many times. Human error is definitely an issue with this type of data collection. So we try to reduce the amount of human error and equipment error, if that's such a thing. We try to reduce that by completing this task several times. We've got 2 more to go. That's 3.72. And then lastly, hit the button, but it didn't stop. We'll try that again. Okay, on that one we got 3.80 seconds. Okay, we have to reset again and move the cart 5 centimeters closer. Okay, so here we are in trial number 3. The stop block is now positioned at 100 centimeters, so therefore the plunger is 90 centimeters from the end of the track. We still have the stopwatch ready to collect the data. We'll record the time that it takes to travel 90 centimeters next. So we will reset the stopwatch and begin. We got 3.59 for that. .59 for that time trial. .72 on that one. Perhaps you can read that better if I angle it a little bit more carefully. .70. Now clearly there is a bit of a delay by the time I press the stop button and when the object actually stops, but the thought here is that if the same person is doing the recording every time, that amount of human error will eventually cancel itself out or be a non-issue. Here we go with trial number 4. I got that one just a little bit early, but we'll keep the data anyway, 3.40. And then lastly, I think that one is spot on, 3.63. Now it is important to note that the person doing the timing here should not be trying to time when this object reaches the end. They should react when the object reaches the end. So we have a more consistent recording of results. And here we go with trial number 4. The plunger is set at 95 centimeters, so it's going to travel 85 centimeters to the end of the track. Got the same stopwatch configuration, ready to go. So we'll reset the watch and begin. Got 3.68 on that one. .75. .57. And 3.43. I think I've got one more to go. I thought that was 5, but according to my table that was only 4, so let's do the last one. All right, 3.65. And for our final trial, we are again 5 centimeters closer. That's been changed and set up. So here we go. Oops, I jumped the gun there. I heard some noises on the track and I pressed the button too soon, so I'll reset and try that one again. Got 3.75 that time. The only time we should throw out data is if we know that there was a clear mistake in the data collection. I don't want anybody to throw out any numbers if they just don't seem right, but in the event that there was a clear mistake while collecting the data, like I've done a couple times now, that's the only time that we should be able to throw out a number. Otherwise, we'll let the numbers sit and then interpret them a little bit later after the data has been collected. Here we go with number 2. It's 3.59. .64. 3.66. 3.66 again. Okay, so that concludes the data collection for table number 1. We have the displacements marked at 5 centimeter increments, and the time that it took to travel each of those displacements is listed as well. So we've got a total of 25 pieces of data. The right-hand side of this table will be used for our computation and analysis. Now, we need to repeat the entire series of data collection again with table number 2. This time we're going to add 2 blocks underneath the end of the track. So we're set up now for the second round of data collection with 2 blocks underneath the cart, or underneath the track. And I do want to point something out here, or at least remind you, that the claim under the background section here was that the acceleration of the cart down the hill ultimately is dependent upon the angle of inclination of the hill. And so what I want to remind you of is that during all of these points of data collection in this first table, the angle did not change. So what's kind of implied here is that the acceleration for this first setup should be exactly the same. Now, we were very careful to measure our displacement precisely, and we placed the starting position of this cart very importantly, or precisely at a specific position. What we're going to do for the second table, just to illustrate the point, and hopefully it'll be it'll work out in the computation when we get there, is I'm not going to specify exactly where the start of the cart is, or the start of the experiment is, and we'll just arbitrarily pick some positions along the way. So coming back to the beginning of the cart, I left this stop block exactly where it is. So our final position is at 10 centimeters. But our starting position, and I realize this may not be focusing well enough, but I'll read it off to you. Our starting position is actually at 126.9 centimeters. It's one tick mark below 127. So when it comes to our displacement, it's worth noting that our displacement for x is equal to the starting position, x naught, minus the final position, x sub f. So in this case, our starting position is 126.9. Our ending position is 10.0 centimeters. So we're talking about a displacement this time of 116.9 centimeters. So let's see how long it takes for the object to travel down this portion of the track. It's a little bit higher here, so hopefully you can see that timer. And here we go with 5 trials. Number 1. That was 2.75. .69. 2.81. Ooh, 3.06. Now I don't believe that was a deliberate error. I think that was recorded just as well as any other, so I'm going to leave that one in there. It may seem a bit unusual, but I believe that we'll trust the data. And here we go with our last one. That one was 2.94. Okay, so again, to test this hypothesis, I'm going to pick some other arbitrary position a little bit closer, at least 5 centimeters closer, and then I'll measure the distance and we'll set up our next trial from there. For this trial, we've got the starting block at the end of the pendulum, or the piston, marked at 121.1. So on our table of data here, we've got a starting position of 121.1 centimeters minus the 10.0 centimeters for our initial position, or our final position, I should say. So that's a difference of 111.1 centimeters for this series of trials. So we've got everything set up as it was before. Reset the clock and collect some data. .88. .78. .98. Oops, I forgot to press reset on that. So again, this would be one of the reasons why we would throw out that number. That was a user error. So let's reset and restart. 2.78. Did it again. I forgot to hit reset. .95, and that was our 5th data point for that trial. So I'll reset and set up another one. In this trial, the start position of that plunger is at 114.2. So the displacement, or starting position, 114.2 minus 10.0 is 104.2 centimeters of displacement. So here we go with our time trials. Trial number 1. Number 2. It's 2.90. .75. That was 2.66. I double tapped the screen, but that was clear enough for me to read. 2.66. Again, 2.66 seconds. And then for our last one in that group, 2.92. So on that trial that I double tapped the screen, if it wasn't possible to read that number before the stopwatch restarted, then clearly that would be a data point that you can throw out. But in this case, again, it was clear enough for me to read, so I was able to save it. So let's set up for another trial. In this trial, the starting point of the plunger is at 108.9 centimeters. So if we're starting at 108.9 and ending at 10.0, we've got a displacement of 98.9 centimeters for this series of trials. And here we go. 2.44. 2.82, 2.79, 2.81, oops, I reset, but I didn't hit the start button. Try that again. 2.72. And in this final trial, we have the beginning tip of the plunger set at 101 centimeters. The ending position is still at 10 centimeters, so 101 centimeters minus 10 centimeters is 91.0 centimeters. So I recognize this camera doesn't focus very well, but I think you can read the timer on my watch or on my phone just fine. But it is worth noting that I'm calling out the times out loud as well. It's not that I don't trust you to be able to read that, but think of this in a group setting. If you've got a group of students that are recording the data off of one person's time, it would be a lot easier for that person that's taking the time to call out the results as they go. It tends to make things work a little bit faster than having all of our students kind of circle around the clock and read that for themselves. So that's just a little tip while doing this type of data collection. And so here we go with trial number 1 at this new displacement. is 2.75. .78. Well, we've got a failure here. There it goes. Okay, let's try that again. 2.75. .53. 2.54. So again, that collects, or that finalizes our data collection. We've got 25 more data points with this particular series of cart rolls, if you will. So what I'm going to do next is take this information and transfer it to my Word document online, and we'll pick up the video from there to continue our analysis.